Welcome to EGBTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this present video, I will discuss about the Telogen's theorem. First of all, what is the statement of Telogen's theorem? That is, the algebraic sum of the powers in all branches. The algebraic sum of the powers in all branches in the given circuit is 0. That is, in the given circuit, in every branch, you have to find out what is the current passing through branch and what is the voltage drop across each branch. Then find out what is the power in the corresponding branch. That is V into I. You have to calculate in every branch. Then adding of all branches, all branches in power equal to 0. That is, the total power coming from the source is equal to the total power taken by the all branches. Okay, that is another statement for Telogen's theorem. That is, you have to calculate the power from the source. Suppose we know the source value is V and current from the source is I. Then Vi equal to then V1 I1 plus V2 I2 plus and like that. That is, we have to find out voltage drop and current in each branch. Then find out the what is the power loss in every branch. Then adding all the powers, then the total sum of the powers is 0. That is, in the form of equation, the Telogen's theorem you can explain is sigma, that is summation. Why? Because in the Telogen's theorem, all the powers are to be added. That's why equation becomes sigma value, that is summation. Sigma k equal to 1, that is first branch to maximum branch. B is the number of branches given in the circuit. Then Vk into Ik equal to 0. That is V1 I1 plus V2 I2 plus V3 I3 equal to 0. Okay, that is in the form of equation. You can write down the Telogen's theorem. And the Telogen's theorem, it can be applicable to, it can be valid for any type of the circuit. That is linear or non-linear, active element or passive elements, time varying element or time invariant element. For any type of the elements, the theorem is to be valid here. And very important point is, in every branch, all the elements must satisfy the Kirchhoff's laws. That is, KVL is also satisfied or KCL is also satisfied. Then, if elements are satisfied KVL, KCL, then it is valid, it is applicable, the Telogen's theorem for the given circuit. That is, for example, I am considering only for general circuit to explain what is the Telogen's theorem. That is, consider one simple circuit and having suppose 3 branches. For example, here I am taking 3 branches. Then this is voltage V, source value, and elements are taken, that is R1, R2 and R3, for example. Then what is our first calculation? We have to calculate after giving the circuit. Then what is the current passing through each branch? Then for example, I am taking current I, which is passing through source branch, and also the current passing through R1 is IR1. Similarly, the current passing through R2 is IR2. The current passing through R3 is IR3. After knowing the values of current passing through elements, then what is our aim here? To find out what is the voltage drop across each branch. That is, across R1 taken as V1. Across R2 it is taken as V2. Across R3 it is taken as V3. Then across every branch R1, R2, R3 branches, we know the voltage drop value and we know the passing current value. Then find out what is the power in each branch. That is, what is the power in the source branch? That is V into I. equal to, that is the total power delivered from the source V into I, that equal to the total power in each branch. What is the first branch? R1. What is the power is V1 into IR1 plus what is the power in R2? That is V2 into IR2, that is V into I combination. For R3, V3 into IR3. Then these two values must are equal. Then intelligence theorem can be verified for the given circuit. Okay. This problem, that is in university examinations also, the problem is compulsory on intelligence theorem. Very easy problem. Just only you can find out each branch current, each branch voltage, then find out each branch power, then adding all powers, then theorem will be verified. That is, I am taking, for example, one circuit to verify the Thevenin's theorem. That is, in the given circuit, you can verify Thevenin's theorem. That circuit consists of one dependent source. That is, voltage source. It can be depends on current value Ix. That current value Ix you have to calculate passing through 2 ohms. That's why the dependent source is called current dependent voltage source. It is voltage source depends on current value. That's why it is current dependent voltage source. Okay. Then what is our step here to find out current through each branch? Okay. We know this branch current is 10 amperes. Then what is the current passing through 1 ohm is 10. Okay. That is current passing through this is 10. Similarly, the current passing through 2 ohms is Ix, we know. Then, what is the current passing through 3 ohms? That is, apply KCL at node. Then, the remaining current is 10 minus Ix. Hence, here in this step, we can find out the unknown current value Ix. Then, apply KVL for second loop here to find out the unknown current value Ix. That is, apply KVL to the second loop. Then what happened? That is, we know the current always passing through the element is from plus to minus. Then apply KVL here. That is what happened. Minus 3, 10 minus Ix. And also for the source, passing current is from higher potential to lower potential. Then 2 into Ix. For element from minus to plus, then across 2 ohms the current, the drop is 2 into Ix, that equal to 0. Here plus 2x minus 2x will be cancelled. What about remaining value here? 3 into 30 minus 3 into Ix equal to 0. From that, the unknown current value Ix is 30 by 3, that is 10 amperes. That is, the Ix value is 10. Then what are the changes in the given circuit here? That is, the Ix value is 10 amperes. Then similarly, what is the voltage source here? That is 2 into 10, that is 20 volts. And what is the current passing through? 30 to 3 ohms, that is 10 minus Ix, that is 10 minus 10 equal to 0. What do you mean that here? Across 3 ohms, the voltage drop is 0. There is no voltage drop across 3 ohms. Why? Because the current passing through 3 ohms is 0. Then what about 1 ohm passing current is 10, then R value is 1, hence voltage is 10 volts. Similarly, for 2 ohms passing current is 10 amperes, R value is 2, then voltage value V equal to I into R, that is 20 volts. Then we know every branch current and we know every branch voltage. Okay. Then you can find out, you can verify Telogen's theorem. That is, what is the, that is from Telogen's theorem, total power that is P source equal to, that is 10 into here, what is the voltage here? Total voltage is 10 plus 20, 10 volts plus 20 volts. That is across 10 ampere source, we have voltage is 30. That is V into I. That is 10 into 30. The power in the source is 300 watts. That is the power value in the source. In the similar manner, you can find out what is the total value here, the total power in each branch. That means power loss in 1 ohm, that is taken as P1. For example, P1. V into I, that is 10 into 1, that is 10. 10 into voltage is 10, voltage 10, current 10, that is 100 watts. Similarly, the power in 2 ohm, passing current is 10 and voltage drop is 20, then total power in the 2 ohms is 200. Okay. Similarly, what is the power in 3 ohms? That is, we know current value 0 as well as voltage value 0. Then there is no power loss in 3 ohms. Therefore, what is the total power? Total power in branches. That is, you can add all branches powers value. That is, we can call as P sink. That is, absorbing the power value. That is P1 plus P2 plus P3. Then what is the value of P1? That P1 value is 100 watts, P2 value is 200 watts, and P3 value is 0. Then total power is 300 watts. Therefore, according to Telogen's theorem, what is here? The sum of the powers, that is total power from the source, equal to total the power in all branches, sum of all branches. Then two values are equal. Hence, Telogen's theorem is verified. Hence, Telogen's theorem is verified. Okay, like that, you can find out what is the total power coming from the source, what is the total power absorbed in each all branches, then adding all powers, then both values are equal. Hence, Taylor's theorem is verified. Okay. Subscribe our channel and share to your friends.